What's up, everybody? It is officially trig season, so now it's time to kind of brush up on, all those old little trigonomic principles, the sines, the cosines, just kind of brush up on all of that. And yeah, we're getting back into it. So the hardest part about trig is kind of just like, I guess, comprehending it. But once you kind of get it down, it's really actually pretty simple. So I'm gonna do my best to try and explain it to you today. And take some notes if you want, and take notes on only what you find like useful to remember. But yeah, anyways, let's get into it. Circle, 360 degrees. Now you may be wondering, like, wait, wouldn't a circle that would be like 2 pi r? That would be like the diameter. Nah, today we're looking at 360 degrees. Now, take a look here. This is what I mean by it. So it's like, it's less about like the diameter, it's more about like the angle measure. So from here, 90 degrees, here, that's 180 degrees, and up to here, 270 degrees, and then 360 degrees. So let's say we're looking at the angle from here, basically, from this line, or from that line. So just like that, that's 90 degrees. If I go like that, that's a 180 degree angle. That's a 270 degree angle. That's a 360 degree angle, Same thing if I was turning in my chair. 90 degrees, 180 degrees, 270 degrees, 360 degrees. That's the circle. And of course, you can split it up into even further. So 30 degrees, 45 degrees, 60 degrees. And then if you were to put it on a coordinate plane and set the radius of the circle, aka half of its kind of diameter, you would get something like this. So it would line up with the points at 0, 1, negative 1, 0, 0, negative 1, and 1, 0. At 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now you can take notes on this if you want, but you don't really need to. But yeah, and then of course, like I said earlier, you can turn this into 30 degrees, 45 degrees, 60 degrees, and basically any degree you want. But these are the important ones, and we're going to see why a little bit later. So 30 degrees, 45 degrees, 60 degrees, and then basically any kind of factor of those. So 120 degrees, 135 degrees, 150 degrees, 210 degrees, 225 degrees, 240 degrees, all that kind of stuff. But guess what? Life isn't fair sometimes, You learn the whole thing, and then, it just changes. So now instead of looking at degrees, we're going to be measuring things in terms of radians. Now, what's a radian? It's basically when you take like the radius, like if I took this and I like stretched it out across the circle, it's going to go around the circle 2 times pi times. So now instead of 30 degrees, that turns into pi over 6. Instead of 180 degrees, that turns into pi. And instead of 360 degrees, it turns into 2 pi. So now you got all sorts of crazy angles. We got pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And you can pretty much relate to these. You can pretty much relate the degrees and the radians pretty easily. Just remember that 1 pi is equal to 180 degrees. So you can say like, all right, so what's pi halves? Well, that's 180 divided by 2. So, that's going to be at 90 degrees. That's where pi over halves is. So, yeah. And, I remember earlier when we were kind of like looking at them. So remember 90 degrees, or now pi over 2 is at 0, 1. 180 degrees, or pi, is at negative 1, 0. Over here at 3 pi over 2, which is 270 degrees, is now 0, negative 1. Then up here at 2 pi, or 360 degrees, it is now at 1. It's at 1, 0. It's still at 1, 0. Well, what about all these angles? What coordinate point are those at? Where's pi over 6? What's the coordinate there? What about pi over 4? What about pi over 3? How do we know what the coordinate point is there? Well, don't worry. Triangles. This is how you kind of figure out where the coordinate point is. And it's pretty smart, but first I'm going to give you a little bit of basic degrees. This right here, basic review. Did I say basic review? I think I said something else. But this right here is the 30, 60, 90 triangle. And the ratio, so the hypotenuse, if the hypotenuse is x, the ratio is going to look like x over 2, then x times square root of 3 over 2. Now I'll show you what that means a little bit later. But let's move on to the 45 degree, 90 triangle. And the ratio for this one is going to be x, which is the hypotenuse, always the longest side, square root of 2 times x over 2, and square root of 2 times x over 2. Now, how do we find out these ratios? Well, they're derived from the Pythagorean theorem. Now, you don't really have to like take notes of this or like really know it, but it's just kind of a good thing to have in the back of your head. So let's say we have a 30, 60, 90 degree triangle here. The hypotenuse is 12, and we want to find these other sides. We could use the Pythagorean theorem, and I'm going to use the ratio too, just to show how they relate. So for a 30, 60 degree, 90 triangle, this side right here is always going to be half of the hypotenuse. So we know that's going to be 6. Now we just need to know this side. So 12 squared So a squared plus 6 squared equals 12 squared. So then we can turn that into a squared plus 36 is equal to 144. Subtract 36. So now we got a squared is equal to 108, I believe. Now we can square root. So a would be equal to, there's a lot of thinking, It would be square root of 36 times square root of 3. So a would equal to 6 times square root 3. So that's how you find a. And as you can see, we can use the ratio here, and it'll just give it to you a little bit quicker. So we have x over 2, then x times root 3 over 2. So let's do that. So 12 over 2, and 12 times square root 3 over 2. And then that turns into 12, 6, and then 6 times square root of 3. So we get the same answer either way because they're derived from one another. So you can use the ratio, just use the ratio. Don't even like, I mean, if you want to, you can use the Pythagorean theorem, but just use the ratio. It'll get you there quicker. If you're solving triangles, a lot of the time you might not even need to solve them. So on to the 45, 45, 90 degree triangle. Let's say the hypotenuse is 8. I didn't leave myself a lot of space here, so we'll just try and work with that. So we'll say a squared plus b squared is equal to 8 squared. And then one thing about the 45, 45, 90 degree triangles, these two sides are the same. So we can say this is just 2a squared is equal to 8 squared. Divide both sides by 2. So that would be, so this is 36, so divided by 2, a squared is equal to 18. Oh no, this is 60. Yeah, this is 64 divided by 2. Then that turns into 32. Square root of that, so a is equal to, we can turn this into root 16 times square root 2, so it's equal to 4 times square root 2. Now look how much space and how much thinking that took. That took a lot of thinking. Now let's just see, oh, I gotta find space somehow. Now let's see how fast we can do it with a ratio. So it's x, root 2 times x over 2, root 2 times x over 2. So that would be 8, root 2 times 8 over 2, root 2 times 8 over 2. So 8 root 2 times 4, or 4 times root 2. I'll just write it like that. 4 times root 2. Same thing, but it looks more satisfying like that. 4 times root 2. There you go. then we got the same answer. So basically these ratios are derived from the Pythagorean theorem. As you can see there, we got the same answers. So, you know, that's kind of a good thing just to have in the back of your mind. So yeah, that's how you solve the 45, 45, 90 degree triangle and the 30, 60, 90 triangle. But why is this important? Because we're going to be putting it on the unit circle. Now remember, for the unit circle, since it's a unit circle, the hypotenuse of the triangles or like the radius of the circle is always 1. And since we're using that radius of the circle as a hypotenuse, the hypotenuse is always going to be 1. So I guess we can kind of just forget about all the little x's for now and just kind of remember this. So 30, 60, 90 degree triangle is going to look like 1, 1/2, root 3 over 2. 45, 45, 90 degree triangle is going to look like 1, square root of 2 over 2, and square root of 2 over 2. And then this is just a 30, 60, 90 degree triangle again, but it's on its side because we're going to have to use that later. So it's the same thing. 1, the long side's root 3 over 2, and then that short side's 1/2. So when we put them onto our unit circle, we can actually find the coordinates because, look, let's just follow this triangle. So this big triangle here, that's the one right here. This value, that's going to be your x value because that's how far out you're moving in the x direction. And then this value here, this long side, that's going to be your y value because that's how far you're going up. So right here at this 60 degree angle, because this angle is 60 degrees, it's a 30, 60, 90 degree triangle. 60 degrees, also known as pi thirds, as we saw from when we were looking at the radians. 60 degrees is pi thirds. So at pi thirds, the coordinate is 1/2 and root 3 over 2. Now we can apply that to the other ones. 45, 45, 90 degree triangle at pi, it's at 45 degrees or pi over 4 radians. And we can use the method, so it's going to go out in the x direction, root 2 over 2 times, and it's going to go up root 2 over 2 times. So the coordinate is at root 2 over 2, root 2 over 2. Then as we have another 30, 60, 90 degree triangle at pi over 6 or 30 degrees. So boom, 30 degree angle there, 90 here, 60 there. And so that's going to be at pi over 6, which is 30 degrees. And we know it's going in the x direction, root 3 over 2 times, and then it's going up in the y direction 1/2 times. So that gives us the coordinate there. And then, yeah, so that's how we use the triangles and kind of relate them to the circle in order to find the coordinates. This is what it would look like if you filled out the entire circle. So look, as you can see, it's the same thing. So like 1/2, root 3 over 2, negative 1/2, root 3 over 2. It's the same kind of things. It's either going to be 1/2 root 3 over 2, root 2 over 2, root 2 over 2, or root 3 over 2 and 1/2. But and depending on the quadrant, because remember, this is going to be the y-axis, this is going to be the x-axis. Sometimes they're going to be negative, sometimes they're going to be positive. So let me show you. So in this quadrant, this is the positive x and positive y quadrant. So everything's going to be positive. This side though, this side, the x is negative and the y is positive. So you can see it's all the same things, but negative. So negative root 3 over 2 and 1/2, negative root 2 over 2 and root 2 over 2, negative 1/2 and root 3 over 2. And yeah, then we go underneath this x-axis, and now both the x and y are negative in this quadrant. So we got negative root 3 over 2 and negative 1/2, negative root 2 over 2 and negative root 2 over 2, negative 1/2 and negative root 3 over 2. Then moving into this quadrant, the x is positive, but now the y is still negative because we're underneath the x-axis, but we are now on the right side again of this y-axis. So 1/2, negative root 3 over 2, root 2 over 2, negative root 2 over 2, negative, and root 2 over 2 and negative 1/2. So yeah, basically all you need to remember is just the 3 different coordinates, like right here, boom, boom, boom. And then just depending on what quadrant it is, either the x or y or both are going to be negative. So that's how you find those ones. And then also don't forget, you know, these little coordinates that we remember from earlier at 0, 1, 1, 0, negative 1, 0, and then 0, negative 1. So here's a little trick, memorization trick to I guess, memorize like what goes with what on the circle. You know, a lot of people are like kind of like about memorization, but I think like once you like understand where everything's coming from, like you can just memorize it, and it makes things a lot quicker, a lot easier. And you know, it could even be a tool to kind of like check yourself. So if you have something, any number, and it's over 4, you can remember 2 times 2 equals 4. Therefore, we're going to use root 2 over 2 and 2. You know, it doesn't make sense mathematically, but it's just kind of a trick to remember. So there's like no math here. It's just trick to remember. So like over 4, 2 times 2 equals 4, or 2 plus 2 equals 4, root 2 over 2, and root 2 over 2. For pi over 6, 3 times 2 equals 6. So our x value is going to be root 3 over 2, and then obviously that's paired with 1/2. So you're just kind of relating it to the first x, and then, yeah. So, and then we got anything over 3, 1 plus 2 equals 3. So 1 plus 2, so 1/2, and root 3 over 2 goes with 1/2. So that's a pretty simple way to remember it. There's no math, there's no reason to it, but I don't know, that's kind of way that I used to remember. Anyways, for anything that's just a pi or anything that's just pi over 2, it's always going to be on an exact coordinate. So either at 1, 0, 0, 1, -1, 0, or 0, -1. So yeah, that's a pretty neat trick to remember like what kind of coordinate is going to go with your measure. So yeah, or with your measure of radians. Anyways, let's move on to the sine, cosine, and tangent. So let's picture this. So we have our triangle on our unit circle here, and let's take it out. Boom, taken out. We got our beta here, and adjacent to the beta, or whatever the heck you call it, is the adjacent. On the opposite of it is the opposite. And then, of course, the h, hypotenuse. Who can forget the hypotenuse? And here's another trick to kind of remember things. SOHCAHTOA. I'm going to show you what that means right now. So one of the trig functions is sine, the most popular one. That is the opposite side of the angle. So in this case, the angle is this little beta thing, or whatever it's called. The opposite side of that divided by the hypotenuse, so over h. So SOH, so. Then the ka is cosine, which is equal to adjacent over hypotenuse. So adjacent side divided by the hypotenuse. Then tangent of the beta is equal to the opposite over the adjacent. So opposite side divided by adjacent side. SOHCAHTOA, so sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Boom. So let's put numbers to it now. So we got our beta here, or beta, or whatever. I don't even know what it's called, low key. But let's say our hypotenuse is 5. This side is 4. The opposite side, the adjacent side is 3. Sine will be opposite over hypotenuse, 4 over 5. Cosine will be adjacent over hypotenuse, so 3 over 5. Tangent will be the opposite over the adjacent, so 4 over 3. Boom. Now it's time to make things a little bit more complex. So here are like kind of like the reciprocal trig functions. So we got cosecant, which is equal to 1 over sine. Remember, they kind of like match up with each other weirdly. Cosecant, even though it says COS, it doesn't go with cosine. So always remember that. Secant is going to go with cosine. Cosecant goes with sine. So make sure to remember. That's why I put that little special note there. And then secant of beta, 1 over cosine. Cotangent of beta is 1 over tangent. So now let's put this into the things. So cosecant would be 5 over 4. Secant 5 over 3, and then cotangent would be 3 over 4. Now you may notice that like these are just the reciprocal answers of these ones. So sine 4 over 5, cosecant is 5 over 4. Cosine 3 over 5 is secant 5 over 3. And tangent 4 over 3 is cotangent 3 over 4. That's because these functions are just the reciprocal of these ones. So cosecant, it's either 1 over sine or hypotenuse over opposite, which is just the same thing. Secant is hypotenuse over adjacent, or 1 over cosine, same thing. Tangent is opposite over adjacent. And cotangent is adjacent over opposite, or 1 over tangent, which is the same thing. They're reciprocals of each other. So, yeah, let's see what else we got. All right, so now if we were going to use these functions on the triangles that are in our unit circle, since the radius of the unit circle or the hypotenuse is always 1, like I said earlier, then we can just simplify these kind of trig functions. So sine of an angle is equal to opposite over hypotenuse. The hypotenuse of a unit circle or the radius is always 1. For example, let me pull it up real quick. This is always going to be 1. Hypotenuse always 1. So this is just opposite over 1, which is equal to opposite. And since the opposite angle, that's how much we're going up, that's always just going to be the y value. So sine of the angle is equal to the y value of the coordinate. So cosine, and this is for the unit circle, it could be different for lots of things. Hold on, my computer's about to die. Alright, well, hopefully my computer doesn't die. Okay, everything's moving smooth. Alright, so same thing with cosine. So cosine is adjacent over hypotenuse, a over 1, so you can just be a. Cosine of an angle, and since a is adjacent, that's just how far along the x-axis it moves. We can say cosine is just equal to x. Now tangent is equal to opposite over adjacent, or y over x. So how far it goes up over how far it moves to the side, y over x. And then of course, since these are just the reciprocal functions, we can just say that they are the opposite. So cosecant is 1 over y, secant is 1 over x, cosecant is x over y. So yeah, now it's time to do a little bit of practice. But first, I gotta charge my computer a bit because it's gonna die. So I'm gonna do a little cut. All right, guys, my computer is now charged, and yeah, let's do a couple practice problems. So I kind of wrote one out here, sine of pi of 6. So how do we solve this? So first thing we're gonna do, gonna draw out our unit circle. Boom, boom. So here's what I kind of like to do. I kind of like to divide it into pies. So this is the top pie, this is the bottom pie. And now, since it's over 6 in the denominator, we're going to divide it out by 6s. So we'll go like that, like that, like that, like that, like that. Boom, 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 boom. All right, good enough. So we're moving 1 pi 6. So the way we do it, we move from right here and we go up when we're going positive. So we're going to move up 1 pi over 6 and we get to here. And since it's a 30-degree angle, pi over 6 is 30 degrees, we're going to be using a 30, 60, 90 triangle. So we can just remember our kind of thing here. So 3 times 2 equals 6, so we know at pi over 6 the coordinate is going to be root 3 over 2 and 1/2. And since we're in the positive quadrant as well, these will both be positive. And then we're looking for the sine, and since sine is just the y value, we look at the y value, and the y value is 1/2. So this is equal to 1/2. Pretty simple. And yeah, that's about as simple as it gets. But right here, I got a little practice paper. If I TA for you, you might have gotten this already. But, you know, there's a lot of different little tricks and little hidden things that are inside of these things. So I'll try and show you some of them. I put a little star next to some of them. So, yeah. Anyways, yeah, let's get started. I don't even have a key up, so if you guys see me do a mistake or I get something wrong, please leave a comment down below, but hopefully I won't get any of these wrong. So we got cosine 5 pi over 4. So we're going to divide this top and the bottom into 4s. Alright, that was pretty bad, but whatever. And we're going to count 5. So 1, 2, 3, 4, 5. So we're going to be over here. 5 pi over 4. So this is 180 degrees. Move it up 45 degrees because we're going by 4s. So we are at 225 degrees. And yeah, so we're going to be using a 45 degree, yeah, 45 degree, 45 degree, 90 degree triangle. And we can remember from our trick, since this is a 4, 2 plus 2 equals 4, we can do root 2 over 2. And we know it's going to be root 2 over 2 and root 2 over 2. And then we can see, since it is in this quadrant right here, both the x and the y are going to be negative. So we got negative root 2, negative root 2. So that is our coordinate. And then we're looking for the cosine, which is the x value. So this is going to be equal to negative root 2 over 2. Boom. All right, number 7. We got tangent of pi over 3. All right, so let's divide the top and the bottom into 3s. Boom, 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 boom. And this is actually a negative pi over 3. So instead of going up like 1, we're going to go downwards. So we're going to go like boom. And then we're going to end up at this one. So positive, we're moving up like this. If it's negative, we're going down. So if this was negative like 5 over 3, we'd be like negative 1, 2, 3, 4, 5. But it's just negative 1 pi over 3. So we're going down here. And we can tell, since pi over 3, this angle is going to be the 60 degree angle. This is going to be the 30, and this is going to be the 50. And we can use our trick. So pi over 3, it's over 3. 1 plus 2 equals 3. So we know the coordinate here is going to be 1/2 root 3 over 2. And yeah, so we know that the y is going to be negative and the x is going to be positive because it's in this quadrant right here. So 1/2 negative root 3 over 2, just like that. And tangent, we know that's y over x. So this is negative root 3 over 2 divided by 1/2. So this is going to cancel out here. So this is going to be equal to negative square root of 3. Boom. All right, let's move into this next one. We got cotangent of 5 pi over 6. So let's do, oh damn, that is so chopped. So let's divide both these sides into 6s. So boom, 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 boom. 5 pi over 6. So we're going to go 1, 2, 3, 4, 5. So that's going to be right here. And then we can see this is going to be 30 degree, 60 degree, 30, 60, 90 degree triangle. And then we can just use our trick. So we know 3 times 2 equals 6. So we know root 3 over 2, 1/2. That's going to be the coordinate. And as we can see, since it's in this quadrant right here, this x value is going to be a negative. So we're looking for the cotangent, which is 1 over tangent. And so the tangent is going to be the y over x. So let's do that first. So this is what the tangent is going to look like. And then since it's 1 over tangent or the reciprocal of that, we can just kind of flip this. So negative root 3 over 2 over 1/2. Boom, that cancels out. And the answer is actually negative root 3 again. Dang, that's crazy. Next up, we got secant of negative pi over 4. So let's divide the top and the bottom into 4ths. Alright. And then we're going negative direction, so boom, we're going to go down 1. And then since it's over 4, we're going to use a 45, 45, 90-degree triangle. Boom, boom, boom. And we know from that, and we know from our trick, since it's over 4, 2 plus 2 equals 4, and because it's a 45, 45, 90-degree triangle, because it's at a 45-degree angle here, we're going to be using these coordinates. So we're going to have root 2 over 2 and root 2 over 2. Then we know the y is going to be a negative and the x is going to be positive because it's in that quadrant. We're looking for the secant, which is 1 over the cosine, which is the x value. So we're going to have 1 over root 2 over 2, which is equal to 2, which is equal to 1 times 2 over root 2. And then we're going to need to simplify that because we can't have square root in the denominator. So we're going to multiply by root 2 over 2, which is just equal to 1, so it doesn't really matter. So this should be 2 times square root of 2 over 2, boom, which is equal to square root of 2. And that should be our answer. All right, next up, we got cotangent of 27 pi over 2. Now, you may be wondering, wait a minute, isn't that more than 2 pi? How are we going to fit it into the circle? Don't worry. So, what we're going to do, we're going to divide it top and bottom into 2, just like this. One thing to remember is since this is going to be over 2, it's basically going to be on these like kind of exact points. I'll show you what we mean in a minute. So now we just got to kind of circle it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right. So we're going to end up right here, which is on the coordinate plane. This is going to be 0, -1, aka, actually, I don't even know what I was going to say there, but 0, -1. Anyways, yeah, so basically when it's over 2 pi, you're just going to keep moving around in a circle until you reach your number. And maybe you just got to do it a ton of times like I just did, you know. Life throws you lemons sometimes, and you just kind of got to roll with them. But anyways, this is our point right here, 0, -1. Cotangent is 1 over tangent, or y, 1 over y over x, also known as x over y. So we can put the x, which is 0, over -1. That's the here, you know what? I'm gonna just go. I'm gonna write it out for you guys. You guys can just skip to that part if you want, you know, if you already got this down. But I'm gonna start because cotangent is 1 over tangent. Tangent is equal to the y value over the x value. So -1 over 0. Then cotangent would be the reciprocal of that. So we'd flip that, 0 over -1. So the answer is 0. Boom. Next up, cosecant of 5 pi. Now this one doesn't even get divided by a fraction, so we're just going to split it up into the 2 pi's of the circle. So we're going to go 1, 2, 3, 4, 5. So we're going to end up here at pi. So the coordinate here is -1, 0, I believe. Yep. And now we're just gonna do what we always do. So this cosecant is 1 over sine. Sine is the y value. So 1 over 0. And then 1 over 0, you can't do that. So this is undefined. Anyways, guys, that is all the questions I starred. Hope you guys enjoyed this tutorial. Hope you guys learned something new. And guess what? If you guys get a 4 on your next test, I will give you the Trig belt. You know, I'm the current holder of the Trig belt right now, but if you guys learn all this stuff, you guys could be the next holder of the Trig belt. And you could put it up your head because you're the Trig champion. Yes, I got the Trig belt. Yes, this could be you right now. This is the Trig belt. It's the Trig belt. Yes. Yes. All right. All right. Thank you, everyone, for watching. If you guys got any questions, you know, just find me or message me or something. And yeah. Bye.